Okay, so bell work, go ahead and pause it and do the bell work, and then when you're done, unpause it, so check it. So they want us to find the solutions to the system, so we're going to graph it. The first one is a quadratic, so we would want the vertex, which is 0, 5, so I'm going to plot the vertex, and then you can put this in your calculator and find points, unless you remember the pattern, which is 1, 3, 5. So from the vertex, we go up 1 over 1, then we go up 1, 2, 3 over 1, and then up 5 and over 1. Quadratic is a U-shaped graph, so the other side of it, you're just going to go to the left and then connect your points to have your graph. So it should look like that. The second equation is a line, so a line is going to have a slope and a y-intercept. So our slope is -1 and our y-intercept is +1, so we start at the y-intercept, which is 1, and then we use the slope, go down 1 over 1, and then the reverse, go up 1 into the left 1, and connect your points. And remember from yesterday, the solutions are where they intersect. So these two are going to intersect first at -3, 4, and second at 2, -1. So two solutions, -3, 4, and 2, -1. All right, you can put your bell worksheet away, take your notes, pack it out, go ahead and copy down your target, your how, and your why. All right, so we copied that down. So just running through the steps really quickly for solving a system algebraically. So we're not doing the calculator, we're doing it by hand. So the first thing is you want to solve one equation for one variable. Next thing you want to do is substitute the expression from one step into this other equation. So basically take the answer that you get from 1, plug it into 2. Third step, we're going to simplify and solve the equation. And then we're going to substitute the answer that we get back into the original equation so we can find the value of the other variable. And then the last thing is we're going to check our solutions in both equations. All right. So the actual first problem that I'm going to do, I'm not going to do by substitution. I'm going to do by elimination. And the reason is the way it's set up. So it's set up to where your x's are right on top of each other, your y's, and then your constants. So it just makes it easier to do elimination. You guys did this in Algebra 1, so it should look familiar. When I do elimination, I'm trying to get one of my variables to cancel out. So if I'm looking at my x's and my y's have opposite signs. The first one's a positive, the second one's a negative. So that means that all I have to do is get this top equation to make the to have the 7 in front of the y. So what I do is I'm going to take that first equation and I'm going to multiply it by 7. So multiply everything by 7. So that becomes 7dx plus 7y equals 245. And then the second equation I'm not doing anything with. I'm leaving exactly as it is. So I just rewrite it. Then I'm going to add them together. So this gives me 74x. The y's cancel. And then add the constants. Gives me 222. Divide both sides by 74, you get x is equal to 3. So now that we know the x, now we need to find the y value. So you can plug this y value into either of the original equations. It doesn't matter, but some equations are going to be less work. So for me, I would pick the first equation because the y is already positive and it's by itself. So there's going to be less steps. So I'm going to take this x value of 3 and I'm going to plug it into the x value in the first equation so I can solve for y. So it's going to look like this. So you should get y equals 5. So we have a solution, which is 3, 5. So the next step is you should always check your answers, and by checking it, it means you take the answer that you get, so 3, 5, and you make sure it works when you plug it into both equations. So I'm going to check the first one. The rest of them, I'm not going to check because I know they work, and I don't want to make the video really long, but you should always check to make sure. So I'm going to check this by plugging it in. So when you plug in the x and the y into both equations, the first one you get 35 equals 35, that's true. The second one, negative 23 equals negative 23, they both work, so that means that 35 is the solution to the system. So it works in both equations. Okay, so next step. So now the rest of the problems, I'm going to do the substitution method. So when I do the substitution method, what I like to do is get both of my equations equal to y. So the first equation, y is already by itself, so I don't have to move anything. The second equation, I have to get rid of that minus 2, so I am going to add 2 to both sides. So this becomes y equals x plus 2. And then I just take both equations, since y is x squared minus 4x, I can substitute it where I see the y in the second equation. So instead of saying y equals x plus 2, I'm going to say x squared minus 4x plus 6 equals x plus 2. So the purpose is so that you only have one variable. Notice that we don't have any y's now, we only have x's. So now I want to solve the equation. You have a power of 2, therefore it's a quadratic. So that means I need to get this equal to 0 in order to solve. So I'm going to subtract x from both sides, and I'm going to subtract 2 from both sides. That's going to give me x squared minus 5x plus 4, and then that'll be equal to 0. Now I have a factoring problem. Factoring has come up again. I told you it's going to be in every unit from here on out, and here it is again. So this is a simple ABC problem because the a value is 1. So that means it's a binomial times a binomial. So x and x, because x times x is x squared. And then for your numbers, you need two numbers that multiply to 4 and add to negative 5. Hopefully you know that would be negative 4 and negative 1, because a negative times a negative is a positive, and a negative plus a negative stays negative. My next step is to take my factors, so x minus 4 equals 0 and x minus 1 equals 0, and then find the value of x. So I get x is equal to 4, x is equal to 1. So I have two x's, which means I'm going to have two solutions. So I need to figure out what are the y values. So same thing that we did last time where we took the x and plugged it into one of the equations to find y. We're going to do that, but we're going to do it twice. Once for 4 and once for 1. Doesn't matter which equation you pick, but again, pick the one that's going to be the least amount of work. So looking at it, the second equation has the least amount of work. So I'm going to plug in my x's to find the y's. So you should get that the first y is 6, the second is 3, so we have two solutions. So you get that the first solution is 4, 6, and the second one is 1, 3. You should check them, but just for the sake of time, I know it works, and I don't want to waste a bunch of time in the video. So, all right, let's move on to the next one. So next one I have y equals x minus 4 squared plus 2, and then negative 12 equals negative 3x minus y. So looking at this, the first equation, y is already by itself, so that's good. Now I want to get the second equation, I want to get y by itself. So for me, what I would do is I would add y to both sides, and then add 12 to both sides. So then I have a positive y, and then negative 3x, and then the 12's over here. So these 12's would cancel out, and then the y's would cancel out over here, and you would be left with y equals negative 3x plus 12. Okay, so now you have both y's by themselves, and we're just going to substitute this in place of this y right here. So I'm going to have x minus 4 squared plus 2 equals negative 3x plus 12. So in order to solve this, I first need to FOIL out the x minus 4 because it's to the power of 2, so I'm going to FOIL that first. Alright, so the x minus 4 to the second power, when I FOIL it, it becomes x squared minus 8x plus 16. This plus 2, I have to make sure I bring that down, and then equals negative 3x plus 12. It's a quadratic because it's the power of 2, so you have to get this equal to 0. So I want to keep my x squared term positive, so that means I would add 3x to both sides and subtract 12 from both sides. So this is going to give me x squared minus 5x. This is going to give me 4. This is going to give me 2 because I didn't do anything with that. Next, I would combine like terms, the 4 and the 2. I could have done that at first. I could have did 16 plus 2, but I didn't. Either way, you should end up with x squared minus 5x plus 6 equals 0. Again, another factoring problem. It's a simple ABC because the a value is 1. So that means it's a binomial times a binomial. So x goes in first because x times x is x squared. And now I need two numbers that multiply to positive 6 and add to add to negative 5. So multiply to 6 and add to negative 5. So hopefully you know those two numbers are negative 3 and negative 2. Next, I want to find what the x values are. So I'm going to take my factors, set them equal to 0, and solve. So I get x equals 3 and x equals 2. Okay, you're not done yet because you have to find the y value because you're finding a point where they cross. So I'm going to take my 3 and my 2 and I'm going to plug it into one of the original equations. I'm going to plug it into the easier one, which for me would be the second one because the y is already by itself. So substitute the 3 and the 2 in. I'll do this in different color. Alright, so I get two solutions. So when x is 3, y is 3, and then when x is 2, y is 6. So those are the solutions to the system. Alright, go ahead and pause it and try number 4 on your own. I highly recommend you don't just watch it through, actually try it, see if you can do it, and then unpause it when you have gotten as far as you can or you think you have an answer. Alright, so hopefully you paused it. First one, y is already by itself, so I'm just going to make the second equation equal y2, so I'm going to add y to both sides, and I'm going to add 7 to both sides. So the 7's over here are going to cancel, the y's over here are going to cancel, so I have y, because I added it to both sides, equals negative x squared and plus 7, because the y's over there are gone. Now, I'm going to substitute x squared minus 1, where I see y in the second equation. So x squared minus 1 equals negative x squared plus 7. And then I'm going to solve. Well, in order to solve this, I have to get the x squared terms together, or I have to get this equal to 0 because power of 2. So I would add x squared to both sides and subtract 7 from both sides. So x squared plus x squared gives me 2x squared. Negative 7 plus negative 1 is negative 8 equals 0. Alright, so factoring, I would actually want to factor out a GCF. So 2, that would leave me x squared minus 4. Looking at x squared minus 4, you could factor that, or you could set it equal to 0 and find the solutions. I'd recommend factoring it. It's a difference of squares because x squared is a perfect square and 4 is a perfect square. So this is going to be x plus 2 times x minus 2. And then you take all your factors and set them equal to 0, so you can find the value of x. So 2 equals 0, that's not true, so I'm not going to have a solution there. X plus 2 equals 0, so x equals negative 2, and then x minus 2 equals 0, x equals positive 2. So I have two solutions, or two x's. I have negative 2 and positive 2. So I'm going to take those and plug those into one of the original equations and find the y values. So this time I'm going to use the first one. It doesn't really matter because they're both pretty simple. So you're going to get 3 for both of them because you're squaring the 2, so even when it's negative, you're squaring it. So my 2 solutions would be 2, 3, and negative 2, 3. So that's where, if we were to graph these, that's where they would cross. All right. Go ahead and pause it. Try number 5. See how far you get, and then from there, unpause it and then check your answer. All right, so hopefully you paused it. So on this one, I actually need to get y by itself in both equations because there's something next to y in both of them. So the first equation, I'm going to move the x squared to the other side. So this is going to become y equals positive x squared plus 4x minus 2. And the second equation, I'm going to move the the 1 to the other side so that y is by itself. So that would give me y equals 2x plus 1. So now I have y's by itself, so now I can replace this y with that guy right there, and then I can solve for x. So x squared plus 4x minus 2 equals 2x plus 1. So now I only have one variable, which is x, and I can solve. So we have a quadratic. In order to solve it, it has to be equal to 0. So I'm going to subtract 2x from both sides, and I'm going to subtract 1 from both sides. I get 0 on the right side, which is what I want, and on the left side, I get x squared plus 2x and minus 3, because negative 2 plus negative 1 is negative 3. So again, simple ABC problem, because your a value is 1, so that means a binomial times a binomial. X and x, because x times x is x squared, and then 2 numbers that multiply to negative 3 and add to positive 2. Hopefully you get that it is positive 3 and negative 1, because a positive times negative is a negative, and when I add positive 3 to negative 1, I get positive 2. So next step, set your factors equal to 0 and get x by itself. So you get x is equal to negative 3 and x is equal to positive 1. So my next step is to plug these into one of the original equations to find the y. So I would actually pick that equation there just because there's less steps. The other one has an x squared, so I have to do a little bit more work. It works out either way. I just don't want to do as much work. So now I'm going to find the y values. So you should get 2 values. The first one is negative 5 and the second one is 3. So my solutions you should get that they are negative 3, negative 5, and 1, 3. So hopefully now that you've done like 4 or 5 problems at this point, this is getting easier. It's just the same steps over and over. Get the y's by itself, set them equal to each other, and then solve for x. Then once you get the x, plug them back in. All right, so the last question, go ahead and pause it again and do number 6. And then once you think you have an answer or you're stuck, unpause it and see what you get. All right, so just like the last one, the y values are both not by themselves, so I want to get the y's by themselves in both equations. So the first one, I would actually add the y to the other side and add the 5 to the other side. So it would look like y equals positive 5x plus 3. So the y and the negative 5x just flip-flop on the other side. And then for the second equation, I would add the x squared to both sides. So now I have 2 equations where the y's are equal to, or the y's are by themselves. So my next step is to take the first y, whatever it's equal to, and plug it into the other y. So 5x plus 3 equals x squared plus 4x plus 1. Okay, we have a quadratic again, surprise, surprise, because it's to the power of 2. I want to make sure that my x squared term stays positive, so I would actually subtract 5x and subtract 3. That's going to be 0 on the right side, and on the left side, I have x squared minus x minus 2. Because 4, positive 4, negative 5 is negative 1. You can put the 1 there, but you don't have to. All right, so again, we have a simple ABC problem because the a value is 1. So it's a binomial times a binomial. So x times x is x squared. So that's what you put in first. And then you need two numbers that multiply to negative 2 and add to negative 1. So that would be a negative 2 and a positive 1. Negative 2 times positive 1 is negative 2, and then negative 2 plus 1 is negative 1. So next step, take your factors. Actually, I'll be right back. Take your factors and set them equal to 0, and then solve for x. So you get two values of x. You get 2 and negative 1. Now you have to find the y value, so we're going to plug them into one of the original equations. Again, pick the one with the least amount of work. For this one, it would be the first equation because it has the least amount of steps. So I'm going to plug in 2, and then I'm going to plug in negative 1 and find the y values. Alright, so you should get two y values. First one is 13, second one is negative 2. So now you just write your solutions. Alright, so you should get two solutions at 2, 13, and negative 1, negative 2. Again, I didn't check the answers for obviously most of them just because I didn't want to make the video very long, but you should always check them. One way to check them is using your graphing calculator. You could put both of these equations because they're both in the y equals format. You could plug it into your graphing calculator and see where they intersect. That's one way to do it. And then obviously if you don't have a graphing calculator, you would just plug in the x and the y and see if it gives you a true statement. So that is it.